The type of structures that have no bending, if they have all axial forces in every single member, we call those trusses. Everything is a two-force member. If you took some kind of bridge building competition class in high school or elementary school, I'm pretty sure you heard somebody say, oh, triangles are the most stable shape. Well, the reason they're stable is that when you make a triangle and you put a force at the node, that will be concurrent forces, and everything in there will be a two-force member. Remember we talked about that? Two-force members. That means all the forces are directed along the direction of the member, and there is no moment. That's the important thing. There's no moment because all the forces are concurrent. Remember, if the forces are concurrent, the moments are automatically zero. Everything will be a two-force member if everything goes into a joint and all the loads are at the joint. Here are examples of trusses. So there we go. There's a nice truss there. Here you can see, look at this truss. All the triangles. This one down here is, these trusses hold up that steel deck, and then you pour concrete over that to make a concrete roof. This looks just like a picture from our book. That's a nice truss, and it's getting a little confusing. I think it's all like this. Anyway, there's a truss. Here's another truss with looks like backwards K's, and on this side it looks like forward K's. Anyway, everything in there is a triangle. Now, this thing here, this canopy that looks like a duckbill, that is also a truss. There's members going like this. There are members going like that. And they're hard to see, but there are also members going like this, making everything into triangles. If you've ever been to a construction site where they're putting a roof up on a house, you sometimes will see on the ground just these stacks of trusses. A big truck will come and deliver these, and they'll be all stacked on the ground like this. They're all exactly the same, and what the crew does is they pick these trusses up and they just put them along the length of the roof. And so you have these 2D trusses, which we're going to analyze in this class. Okay? And you make a 3D building, because we live in a 3D world, by putting these trusses up in series. In this case there's only two, but in a roof on a house you have lots of these things. But to make this picture easier to understand, I'm just going to draw two. And then you have to connect the trusses this way so you can put the roof on. And these members here going this way, traditionally on a roof, we call those purlins. Again, another name for beams. But specifically for roofs, the members that go across the parallel trusses are called purlins. Here's a project that we made in Kenya 2 years ago. We welded these trusses together. We made them out of steel because you can't really get wood in Beta, Kenya. They burn it all for fuel. And so we bought steel tube. We happen to have this guy here, Brett Prettyman. He is a master welder. He used to be in a shipyard welding ships. He could weld anything, and so these are actually beautifully welded, and we taught someone how to make them. We made the first 2 or 3 and then had them make the rest under our supervision. And you can see here's the truss. Okay, it's 22.5 degrees, and we did a lot of geometry. It was more complicated than you think to cut these to fit exactly. And then we made a series of them, and then across them we put in these Z-shaped, these actually have a Z cross section, purlins. And so here you can see all the purlins going across, and eventually we're going to put a metal roof over that, and here it is. It's actually done now. These pictures were before it was completely finished. At this point, we still have to put in the lights and things. This happens to be kind of a seismic area. They don't know that there, but according to the geology, the seismicity is equivalent to roughly San Francisco. And this is actually a seismically resistant building. Now we're getting off the topic, but we have these concrete columns like this surrounding the masonry, and this makes for a seismically resistant building. It's the only seismically resistant building there. It's above and beyond what they normally build. We have this ethic within EWB to use the techniques typically used in the area, but in this case, this was going to be a dormitory housing 60 orphan girls, or not all orphan, 1/3 orphan and 2/3 young girls. We did not want this to collapse on them, so we designed it to these higher standards. These are actually not U.S. standards, they're Mexico standards. We don't do this type of construction in the U.S. But anyway, that's a plug for EWB. That was a fun project. Sadly, the dormitory never got used because nobody could afford to live in there. But that's another aspect of engineering, is the societal aspect of things.